Hello everyone, I am Neal Fridhi and I am an application modernization specialist and I work at Google Cloud as a technical sales. I am very happy to be talking in the first edition of Secure Chain Coin, and I'll take this opportunity to thank all the team for these initiatives. To start the agenda for today, I will start with introduction, then I will talk a bit about Salsa framework, and I'll then finish with the Google Cloud Software Supply Chain Security. As I don't have a lot of time, I have only 15 minutes. I will put my contact in the end of the slides, and you can contact me if you want to know any further details about technology that I will be discussed in the slides. So without further ado, let's start. And to start off, let's talk about software supply chain security challenges. What challenges are we solving here? And to do so, most modern software products are typically made up of the source code your organization directly writes, as well as third-party software in the form of dependencies. A build process then combines this source and outputs packaged software, which in turn can be run directly by your organization or consumed by other parties as their dependencies. These dependencies used can be either open source or COTS products, but in either case, that software will have contributors, an SDLC process as well of its own, and its own third-party dependencies. So it's like a loop where we have a lot of other software supply chain, and it's very difficult to find out where the problem comes from. Now the supply chain attacks are on the rise. So we see a lot of reports saying that, for example, from Sonatype, 650% surge in OSS supply chain attacks, 84% commercial code base have OSS vulnerabilities, and 45% of organizations worldwide will have experienced attacks on their software supply chain by 2025 from Gartner. So that's why we need to think about the security of our supply chain and try to implement the best practices in order to avoid problems in our software supply chain development. I will start with some attacks that you may know. So, for example, the SolarWinds attack. SolarWinds had their KMS compromised, which resulted in the build system getting compromised. And this compromised thousands of organizations, including government agencies, because a lot of government agencies and organizations, they are using SolarWinds in their environments. The second attack that you may saw was in 2021, where attackers breached CodeGov, a code coverage reporting tool, as you might know, used by numerous developers. They altered the software bash uploader script, potentially exposing sensitive credentials and data from CodeGov customers. So this the red blocks here show where the surface of attacks was on the CodeGov attack. And the last attack I won't talk about, which is a very popular one, because Log4j is a very popular dependencies, and it's used by a lot of customers and a lot of organization and a lot of developers. And a critical vulnerability was raised in 2021 and allowed remote attackers to execute code on affected servers, potentially compromising millions of applications and devices. So, as you might know, these attacks highlighted the devastating potential of supply chain attacks, where a single compromised component can impact a vast network of users, and there are many attack vectors, as you see here in the slide. So we have here, like, when the person start to code, they can inject bad code. After the code, you can compromise source control, build from modified source, not the original one. So we have a lot of surface attacks or attack vectors. So the challenging that we are solving here can be divided in four categories. OSS proliferation. So nearly most of the tools are based on OSS dependencies. Increasing pace of deployment. Today we deployment frequency are increased, so we deploy sometimes 2 releases per day, 1 release per day. It's not like 4 years ago or 10 years ago, because we have a lot of good tools that allow us to do that. And as well, our customers are always asking for new features and asking for improvements. Also, many attack vectors, how we can secure or reduce these attack vectors, and also standards and tools. So this as well, no end-to-end enterprise class product solution on the market. So this is something as well that we don't have today in order to secure all the supply chain, and we need to resolve. And to address all these challenges effectively, we need a tool or framework, and that's where the SALSA standards comes into play. Okay, so what's SALSA framework? SALSA framework actually it helps us automate analyzing artifacts, guarantee original source code, protect against interference in build and distribution processes, isolate any hidden vulnerabilities, knowing which components are affected by vulnerabilities. So basically, SALSA framework, you can think of it as a tool that tackles three theme or three components: the build integrity of your code, the source integrity, and the dependencies that are used. And in SALSA framework, we have, I don't know, for those who were very attentive to my initial slides about attacks, you may have noted some specific letters where attacks occurred. These are methods used by SALSA framework which helps to distinguish between various types of attacks. So for example, if we see the A attack, it's like a source thread attack, which is submit unauthorized change. The B, it's as well a source threads, which compromise source repo, and so on and so forth. So this is the different, let's say, attack vectors that we can find in our supply chain, in our software supply chain. And then we will define in the next slide levels. So SALSA outlines different security levels for software builds. So for example, SALSA level 1 is like a foundation ensuring transparency by requiring automation and provenance of the build processes. Then the SALSA level 2 adds temper resistance, version control, and signed provenance. And finally, for example, the SALSA level 3 is when your builds are fully trustworthy. So with identity attestation, each images that you're gonna build gonna be attested in each step, and then it will be deployed only if it's attested to deploy to your runtime. And you can see salsa.dev, which is the website where you can find all the levels with more details than that about SALSA framework and SALSA levels. Okay, now what's Google Cloud Software Supply Chain Security? So as you might know, I don't have a lot of time, so it's only an overview to talk about how we can have a supply chain security and what product we're gonna use in order to secure our chain. But if you need other information about that, you can ping me. Okay, so the Google Cloud Software Supply Chain Security tackle different parts in the software supply chain. So from development, we shift security left to EDE. So we have tools in order to test the tool environment, in the developer environment, before going to the source control and before going to the build, for example. After that, in the build as well, in the build, in the supply, so we have trusted portfolio of OSS packages. We have something called assured OSS. I will go in the next slide and explain. So we have dependencies that we are checking them, scanning them all the time in order to verify if there are vulnerabilities within it. And third, the CI/CD, so which is the build provenance. So I have a Docker image that I've built in my supply chain. How I can verify it's coming from my supply chain, and I'm not deploying, for example, in my Kubernetes cluster or whatever runtime another image is coming from another thing. So this is what we call the build provenance and policy evaluation. And the fourth thing, which is misconfiguration analysis, and as well continuous validation. So if, for example, a dependencies that shown in the future, that will show a vulnerability, so we will keep scan your runtime, and then when we find dependencies that are not good, we will notify you that there is something not good in your cluster, which is running in production or which is running in staging or whatever. So this is like the four, let's say, um, uh, domain that we tackle in the software supply chain security in order to have your pipeline or your supply chain secure. So this is to show you the tools that you can use in order to secure your supply chain. So we're gonna start with Cloud Workstation. It's just an EDE based on VS Code or JetBrains if you are using, for example, IntelliJ or PyCharm or whatever. And then Cloud Code is just an extension that you can have on Cloud Workstation in order to scan and to do the integration with Google Cloud. Then we have Cloud Build that we're gonna be used in order to build the application assured OSS that will, be used as a proxy in order to get the dependencies and verify if the dependency is good or not. So we have like a repository that contains verified dependencies, OSS dependencies. Then artifact registry, so it's where we will analyze our images, but before that we have a triggered scan to scan if the images that we was built before is good or not, and then we will generate what we call images metadata in the artifact registry, which is metadata about the images that we have built. After that, we have Google Cloud Deploy, which will be used in order to configure your deployment strategy, whether you want to do a canary deployment or blue-green deployment or whatever. So this is where will be configured, and then binary authorization, it will be in front of your runtime, and it will verify if the images that I'm going to deploy on Kubernetes or on Cloud Run, it's allowed to be deployed. So it's attested to be deployed. This is where I will deploy only the images that I need to, that I want to deploy in my cluster. Not images, for example, coming from other developer that didn't follow all the pipeline. And it uses actually a native features of Kubernetes, which is called admission control, that verify that the images is allowed to be deployed on Kubernetes engine. It's like a policy that we can check before deploying the image. So, and to speak about open source more than Google Cloud products, because maybe most of you don't know about Google Cloud products. So it's actually the same thing as using VS Code, as I mentioned, using Cloud Code, which is open source extension that you can install, using whatever build tool that you want, Jenkins, GitLab CI, whatever, having a package or repository, a registry like Harbor and Artifactory or whatever. Scaffold is a tool used already by Cloud Deploy under the hood, but it's used in order to deploy, to Kubernetes or Cloud Run or whatever. Graphies and Grace are open source tools that can, uh, do the attestation thing about the provenance and the images, verify the images metadata and so on and so forth. and finally deploy to, as I mentioned, Kubernetes. Don't need to use, Google Kubernetes engine or other managed platform. And also cloud native, which is Cloud Run actually is another implementation of cloud native. Okay, so by doing that, a software supply chain security, to be secure and having the right, let's say, configuration, and avoid the attacks, we need to be aware of our platform, build a deeper understanding of your overall postures, and monitor every step in your supply chain. The action as well is very good, so remediate based on best practices, incorporate security practices in your process, automate. So you need to automate all remediation, or as well, if there, for example, an image that contains vulnerability, don't push it, and try to verify that with just a script in your pipeline. And audit. So always have checks about continuous validation of my environment, or it's if it's always good or not, if the dependencies that I'm using in my software are always secure, or there are a vulnerability that was found lately and I need to change, or I need to upgrade, or I need to update to another version. So this is as well is a very important thing to do in order to keep us secure when we are talking about software supply chain security. And yeah, thank you very much. This was my talk about software supply chain security. And don't hesitate to connect with me on LinkedIn, GitHub, or Twitter, X. And yeah, thank you very much. Bye bye.